Hello everyone. Today I'm going to teach you a topic, probability. I am Mr. Chang, or you can say Yuan. Okay, I'm a professional math and computer science teacher with several years experience teaching math and computer science. Okay, let's start today's course. First of all, theoretical probability. Please repeat this after me. What is a theoretical probability? Theoretical probability is the probability that an event occurs when all of the outcomes are equally likely. Okay, equally likely. What does that mean? It's so abstract. We take a look at the example. Okay, equally likely. For example, if you roll a fair six-sided die, sorry, here fair six-sided die, a fair six-sided die to look like this: 1, 2, 3, 4, 5, 6. Okay, each number from 1 to 6 has one unique side. Okay, and if it's a fair die, okay, if it's a fair, then we can say the chance of each side appearing should be equally likely. So the probability of the dice one is equal to dice two, equal to dice three, and so on. The second example is that if you both a fair two-sided coin, we all know that both a coin has two sides. Okay, the first side is the head, which means it has a human's head. Okay, and the other side is called tails, which doesn't have a human's head. Okay, both if both the heads and the tails, sorry, it's called the tails have the same chances of appearing, then we say probability of heads is equal to probability of tails, and we say it's equally likely. Okay. So if you are solving a math questions, when the question states that a die or a coin or something is fair, if say it mentions fair, then we know that the probability for each outcome is equally likely, just like the coin or the die we mentioned before. Then we can write down the probability of heads is equal to the probability of tail, because each outcome for a coin is head and the tail, head or tail. For die, the outcome might be 1, 2, 3, and so on to 6. Okay, each probability will be the same. P hat is equal to P tail, P1 is equal to P2 to P3. Okay, but what if it's not equally likely? In this case, a question will always specify a different probability. It will mention, for example, it will tell you that P hats might be 2 over 3 and P tails might be 1 over 3. Okay, the question will tell you the different probabilities. Okay, till now, any question? If we don't have any question, we just keep going. Moving to the next topic. Oh, here comes the most important thing. So how to calculate the probability of a certain outcome? This sign means probability of a certain event is to find out the number of a certain outcome, to divide by the number of total possible outcomes. What does that mean? We move to a real example. Okay. For instance, if we roll a fair six-sided die, we know the outcome to be 1, 2, 3, 4, 5, or 6, right? So the number of total possible outcomes is 6, right? The number of total possible outcome is 6. But what about the number of side 1? There's only one. There's only one event right here. Okay, so it's 1. So the probability of rolling a die with outcome 1 is the number of side 1 is 1 to divide by the number of total possible outcome is 6. So it's 1 over 6. Okay. Any problem now? If we don't have any problem, we move to the next slide. Oh, let's move to our question today, exploration 4. Please check your question and read the question with me, okay? Randomly choose, let's start, okay? Randomly choose an integer between 1 and 30. What is the probability of choosing a multiple of 3 or 4? Probability of a multiple of 3 or 4. To solve the question, we should move back to our definition. What is the definition of probability? Here, the definition of probability means the number of certain event divided by the number of total possible outcomes, right? So step 1, we should solve the numerator or denominator. Okay, let me tell you, we always find out the number of total possible outcome first, because it's always easier than the certain event. Okay, the number of total possible outcomes. Move back to the question. The question say, we randomly choose an integer. We randomly choose an integer between 1 and 30. So we randomly choose one integer between 1 and 30. So there might be 1, 2, 3, 4, 30. Okay. Yeah, 30 possible outcomes. So the number of total possible outcomes is 30. Okay, we already solved the denominator. Next one, we need to find out the number of multiple of 3 or 4. Step 2, find out the number of certain outcome here, which means we need to find out the number of certain of multiple of 3 or 4. Okay, many students might be confused about this. What does that mean? Multiple of 3 or 4. Okay, first of all, what is the multiple of 3? Multiple of 3 means that a number which is divided by 3 and the remainder is 0. For example, like 3, 6, 9, 12, 15, and so on. Okay, but here comes the question. How many numbers are the multiples of 3 from 1 to 30? Could you spend 5 or 10 seconds to think about the question? I can recommend you to write out all the numbers and try to find out the basic rules. Okay, we stop for pause for 5 seconds. Okay, does anyone want to answer my question? Okay, it's okay. Let me explain the question, the answer for you. If we list all the number 1, 2, 3, 4, 5, 6, 7, 8, 9. If I put 3 numbers into one group, okay, it's a one group, it's a second group, it's a third group, we can discover one thing. The last group should be 28, 29, and 30. If we put 3 numbers into one group, we can discover one thing is that for every 3 numbers, there is exactly one number, which is a multiple of 3, right? This is a multiple of 3, this is a multiple of 3, and this is a multiple of 3, okay? If we have 30 numbers and we divide them by every 3 number, then how many groups do we have? It's easy, we have 10 groups here. We have 10 groups here. So we should have exactly 10 distinct numbers, which are multiples of 3. So we find out the rule. If you are from 1 to 30, it means that you have 30 numbers. Because you are asking the multiple of 3. So we should group every 3 number together. So we divide by 3. And there will be 10 groups. For every one group, there's only one number, which is a multiple of 3. So we find out how many number are multiple of 3. It's 10. So next time, if I ask you, how many numbers are multiple 3 from 1 to 300? How can you do? Yeah, that's right. If 300, we just do it again. 300 divided by 3 means there are 100 groups, and so there are 100 distinct numbers. Numbers are multiples of 3. Okay, just additional question. So let's move to the next question. Till now, we already find out the multiple of 3, okay? So the next one, we should find out the multiple of 4. Again, multiple of 4 are 4, 8, 12, and 16, right? So this time, please try it on your, please give it a try, okay? How many numbers are multiple of 4 from 1 to 30? 3 seconds. Yeah, it's the same. We use 30 to divide by 4, and then we find out it's 7, and the remainder is 2. It means that if we group every 4 numbers together, like 1, 2, 3, 4, 5, 6, 7, 8, and there will be 7 distinct groups. 7 distinct groups. But what does remainder 2 mean? What does that mean? Anyone can answer? Can anyone answer me? It means that there will be 2 numbers which cannot be grouped into which cannot put into a one group, because 4 numbers form a group. There are only 2 numbers, so they will be left over. Okay. The key is here, 7. We find out the quotient is 7, so we can say there will be 7 distinct groups. 1, 2, 3, 4, 5, 6, and 7. Okay. If there are 7 distinct groups, for each group, there will be exactly 1 number, which is a multiple of 4, right? So we know that there will be 7 numbers which are multiples of 4 from 1 to 30. Okay, till now, any question? No? Okay, let's move to the next one. So we already know the multiples of 3 and the multiples of 4. So should we just add the number of multiple of 3 and the numbers of multiples of 4, sorry, here, multiples 4 together? So is the number of multiple of 3 or 4 is 10 plus 7? Number of multiple of 3 is 10. Number of multiple of 4 is 7. So number of multiple 3, 4 should be 10 plus 7, which is 17. If you agree with that, please raise your hand. Okay, let's move to the next one, and I will show you the answer. I'm sorry, no. Why? That's the reason. Multiple of 3, if we list all the numbers, there are 3, 6, 9, 12, 15, 18, 21, 24, and so on, right? Multiple 4, and so on, right? Did you mention that? Did you notice that 12 and 24, and there might be some number in the future which will be duplicated and they will be counted for twice. When we say 10, means that when we say the multiples of 3, there are 10 numbers, so multiple of 3, then we say 3, 6, 9, 12, 15, 18, blah, 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 blah. And we say multiple of 4, there are 7 numbers, right? But for numbers like 12 or 24, they are counted for twice, right? They are counted for twice. So if you just add 10 and 7, there will be duplicated outcomes. Okay, we should minus the number of duplicated outcomes. What is the duplicated outcome? It's very easy. It's just the multiple of 3 and 4. When we are trying to find out multiple of 3, we find out 12, 24, right? And when we are going to find out multiple of 4, we find out 12 and 24. So the numbers which are duplicated is the number which is both the multiple of 3 and 4. Oh, so it means that we have to find out the multiple of 12. Okay. According to the rules we found, we already learned the last 2 pages, right? We use the total number to divide by the multiple of something. So we have to find out if we need to find out a multiple of 12, we just use 30 to divide by 12. and is 2, remainder is 6. It means that there will be 2 groups. So there will be 2 numbers which are multiples of 12. And there will be 6 numbers left over which which cannot form a complete group. So just ignore it. Okay. So we already know that there were 2 numbers counted but twice. So we need to deduct the duplicated outcomes. Okay, here I want to show you with a Venn diagram. Suppose it's a multiple of 3. We find out there are numbers. It's a multiple 4. There are 7 numbers, right? Since our purpose is to find out this one, how many numbers in this area, just like finding out the surface area of the shape. Then, if you use the non-multiple of 3 here to add the non-multiple of 4, did you notice that in the middle section here, you will count it for twice. That's the multiple of 12. So next time, if you find something, it's a multiple of 3 or 4, find out or, we should do something. We should add the multiple of 3 first and the multiple of 4. Sorry. We add them together and you will find out in the intersection part, it will be overlapped. You will be counted for twice. We need to deduct the intersection part, which is the multiple of 12. So we use the number of multiple 3 plus number of multiple 3 is here, plus number of multiple 4 here. And since it's overlapping, it counted for twice. So we need to minus the number of multiple of 12 here. We need to minus this section. So it's 10 plus 7 minus 2, which is 15. Okay, go back to the problem. P probability of 3 or 4, multiple 3 or 4 is the number of multiple 3 or 4 divided by the total outcomes, right? So in the previous slide, we already know that a certain outcomes number is 15. So we use the 15 to divide by 30. And it's 1 over 2. So in this question, we should select D. Okay, in this question, just to have a quick recap, the thing it want to teach us is the multiples. First thing, they want to teach us how to find out the multiples of something. Find out the multiple of something of a certain number, like a 2 or 3 or 4 or 12, from a number from 1 to something, from 1 to 40, 1 to 50, from 1 to 60. The basic rule is very easy. We just use 30 to divide by the multiples of something. For example, it's 4, then it's 7 with a remainder 2. Then we know there will be 7 numbers which are multiples of 4, okay? It's the first thing we need to know. And the second thing we need to know is the Venn diagram, okay? If it's multiple 3, it's multiple 4. If it's multiple 3 or 4, then we need to find out this area. This area will be this one at least 1 minus the intersection part. Okay? You know any question? Raise your hand if you have any question. Okay. Feel free to ask question and interrupt me. Okay, if you don't have any question, we need to move to the next one. This question is much easier than the last one. It's called, okay, practice 4.1. Please read the question loudly with me, okay? I want to make sure you catch up with me, not just spacing out in front of the computer. Okay, a board game spinner is divided into 3 regions labeled A, B, C, and C. Okay, I make a picture to tell you it's a game spinner. It's a game spinner and there are 3 sections, A and B and C. Okay, so your pointers will stop at either A or either B or either C. This will not be ambiguous area like here. Okay, no, just A or B or C. okay? The probability of an arrow stopping at the region A here is 1/3. The probability at the region 2 is 1/2. Then what is the probability of region 3? Think about it. All the possible outcomes are stopping at A or B or C. You have only 3 options. So think about it for 3 seconds. Okay, let's review the answer. Key concept is that the sum of the possibility, all possible outcomes is always 1. Is always 1. Okay, so possibility of stopping at A and stopping at B of stopping at C is 1 because the arrow can only stop here or here or here. There's only one choice, and PA plus PB plus PC is 1, right? PA is 1/3, PB is 1/2, PC is unknown, which is the one we need to find out. So we just sum up these together is 5/6, and move the numbers we don't want to know to the other side. It becomes 1 minus 5/6 is 1/6, so it's B. Okay, just like when you are tossing a coin, right? The P hat is 1/2, then the P tails is 1/2. Okay, suppose it's not equally likely, then it tells that the P hat is 2/3. Then the P tails becomes what? 1 minus P hat, which is 1 minus 2/3 is 1/3. Okay, here's today's course. If you have any question, feel free to ask me. Thank you very much. See you next time.